Topos is an international nonprofit research institute with a focus on shaping technology for public benefit by advancing particularly sciences of connection integration or science of collective sense-making. And our sort of intellectual lineage comes from the category theory community. So we come from this very mathematical approach, looking at how in some sense, the process of production of abstractions. So how abstractions can be created and how they can be interrogated and evolved and compared and so on. So that notion of abstraction is fairly core to what we do. It's at once we believe in sort of the radical power of advanced mathematics to, in more detail, capture what we deeply value and we care about as humans in the world. But also we are aware, we want to advance this in a way that's very aware of its limitations, and we're cognizant of where, you know, these sort of systemic things, these abstractions, these sort of these structures in society can sort of contravene on what is sort of lived and precious to people. And so that's the question, right? How do we get the benefits of these sort of research advances and deploy them into technology and have them engage with society, but do it in a way that respects and builds the society that we as a collective, as a society, want to build.
That's why I really wanted to involve you in this documentary and these questions. Because as I was saying, we are also exploring this idea of math as a language, a discipline that needs to be expanded, needs to be opened up, because we find it a little bit rigid in terms of like, you know, from the studying of it, the language of it, and which eventually could limit also the potentials, potential for everyone, but also for math itself. So there might be also some new math that we don't know, we don't discover because of those limitations. What do you think about that?
Right. That is a perfect articulation of a core part of the purpose of this organization, to really explore that question. So
nice.
I appreciate your assistance telling the story.
Nice, okay. And what do you think about this idea that quantum, I wouldn't say quantum computing per se, but let's say a combination of quantum mechanics, quantum just physics, quantum math, all together is bringing to light a new wave or a new era of mathematicians and schools, and of course with that also discoveries, staying always within math. So not, of course, then they can be applied to science, to computing, and so many other things. But I know you're not a super expert in quantum, at least you don't want to claim so, but you did have your PhD in quantum computing. So I was wondering for you, if because a lot of people now talks about quantum computers mostly, but what is from the math that can emerge from this new way of looking at things?
It's difficult to know in advance. I think what's really interesting about the ways that people are mathematically or sort of conceptually exploring quantum mechanics is that it's a very difficult and very foreign problem, and so it requires new ways of thinking and new ways of encoding the robust thought patterns. So you, as you sort of think in different ways, and you find what ways are reliable or insightful in this particular setting, you start encoding the relevant, the interesting thought patterns in language and mathematics.
Quantum mechanics could reveal some new logics, some new math that actually might demonstrate that that fundamental principle of the RCA can be actually breakable in a way, easier way, because once you have the logic, you can replicate the logic even on paper. You don't even need the computing, right?
A lot of our world is built on these mathematical assumptions, these abstractions. For example, you know, cryptography is a good one at hand, right? There's this problem that there's this mathematical abstraction of factorization of integers, and we have these sort of the scaffolding around it that shows that this particular problem is computationally incredibly difficult. So then on that assumption, we build, our secure communication systems, which are, used every time we swipe our credit card. Built on these abstractions, always the possibility of, to use this metaphor of breaking these abstractions, or a breakthrough or shattering, this idea of a sharp discontinuity. That is, what does it mean to break something? If I have a stick, I'm not bending it. There's no continuity. It's suddenly in two pieces, right? It's a real sort of permanent and sudden change, and we're not breaking sort of a local physical object. We're breaking some of the sort of fabric of modern society. And so, if you're working in a space where we have the potential to do that, how do you do that in an ethical way? Who are the stakeholders? The stakeholders are not just this small group of mathematicians in a university or in a research institute. It becomes this sort of very widespread, diffuse set of stakeholders across the country you live in, across the globe. And I think there are real questions around, institutionally, how do we take that seriously, and how do we build the processes of doing sort of new mathematical work and technological work that take seriously that it's not just the mathematicians, it's not just these sort of curiosity-driven researchers that are affected. It's my grandmother living in Malaysia or something like that in a completely different setting. There's still a lot of work to do, and it becomes very urgent work because of how deeply interwoven these mathematical abstractions are into our society and global society, and how quick these advances can now happen. So quantum is an example. Maybe in 10 years there will be a breaking point like that. Who is deciding? Who is consulted? Who has buy-in into this idea that we're going to change society and in this way? How do we respond to it? And it's not just mathematicians, right?
Right.
It's changing the process of mathematics,
Right.
the practice of mathematics.
Yeah. This is a very particular example where math can change completely society,
Right.
and politics,
Yes.
and many other things worldwide, because
Right.
we are so dependent on the digital world,
Right.
that is dependent on this simple mathematical assumption. I mean, if you really think of the chain, that we start from this simple equation,
Right.
a relatively simple equation, but it's not even an equation, it's assumption,
Right.
actually, a scientific assumption, just because we believe in that way. And it goes all the way to any kind of communication systems we have
Right.
today in place worldwide.
Right.
And
Right.
so it's quite a story.
Right. So, and it becomes, doing this work even in sort of this detached, scientists and particularly mathematicians have this culture of pride in somehow being detached and objective, so to speak, in their work. And there's a long history of this. So if you read something like A Mathematician's Apology by Hardy back in the early 20th century, he speaks with a point of pride, working in number theory, about how useless his work is, how much of an pure art form it is. One of the great ironies is that his particular field of study, number theory, became incredibly influential in cryptography, which became politically incredibly important in sort of World War II and in this sort of in this modern society, as we've been talking about. So it turns out it wasn't really as useless or apolitical as he thought. Nonetheless, I think the culture of mathematics departments is to really view the process of mathematics as this sort of intellectual, as this pure, detached exercise with perhaps either no political edge or valence or consequence, or even if there is, political impact, it's not for the mathematician to care about and engage in and be open to and be consulted within. And so one of the motivations for sort of leaving that environment of work and trying to construct a new culture of mathematics research at Topos is to try and take that question more seriously and view, again, mathematics as part of a process of building up society, and in sort of to take a more personal lens, to reflect on what I call, or what I think about as a loving practice of mathematics.